weekend. We are back at it for another week of math. We have a nice full week this week, and we're going to enter into our last topic that we're going to be discussing for this term. We're going to be trying to just make sure that we have all the knowledge that we need to really work through expressions and equations and know the difference between the two, just getting us a good working knowledge. And we might even get into some combining like terms and things like that, but we'll see how far we go there. So of course, as we start every week, I'd like you guys to start with your pre-assessment. So I'm gonna make sure that to log in there and work through that. So I'll just show you guys how to log into that really quick. So make sure you're in Math Skills 5, right, with me. And then you want to scroll down to the bottom for week 10, Intro to Expressions, and make sure you just do that pre-assessment that's at the top. So it's the thing with the little puzzle piece, and I'll rename it because it should say Intro to Expressions pre-assessment. And that's what you guys are working on. Okay. So make sure you guys work on the Intro to Expressions pre-assessment. I'll give you guys some time to do that. If you finish early before the other students, you can do the discussion post. And also I'll put back up the PowerPoint slide that has a question for practice on there as well. All right, so that's what we're working on right now. We're gonna work on the Intro to Expressions pre-assessment. And then once you guys are done with everything, we'll get started with class.
It's not letting me do it.
All right, let me double check. It could be one of the settings is off. Yep, definitely had a setting off. All right, so refresh and try again. You should be able to get into it now.
Okay.
All right, so feel free to continue completing your pre-assessment. I'm going to work through just giving us some announcements and updates about the week. So I just wanted to start that off while you guys are finishing up. Um, if you have not completed your intent to return form for next semester, make sure that you complete that. Today I saw a couple emails from a few of you that you guys completed the form. As long as you filled that form out, you should be good to go. This is the final week of on-site tech support. So if any of you are continuing to have problems with your device or whatever devices you've received from Academy of Hope and you're not getting the help that you need in person, on the phone, excuse me, make sure you go in person today or Wednesday from 10 a.m. to 4 p.m. To get that assistance. All right. Always make sure to continue checking the homeroom course in Schoology for any weekly updates. There will be 2 chances to win for trivia this week. Trivia rounds 9 and 10 will be posted. So you will have 2 chances to win this week. All right. Reminder, of course, that classes are supposed to begin again on January 11th. We don't know exactly what that's going to look like. It might be the same, it might be different, but January 11th is when classes are supposed to start again. Um, Also remember that CASAS testing is supposed to take place the week of December 14th. We will let you know when you need to come in and do that test. Um, we don't have a schedule yet, so once the schedule has been finalized, the net will be sent out to you all. And I think those are all the announcements. I think a few of you are still wrapping up your pre-assessment. So please continue to work on that. I'll give you a couple more minutes and then we will get started with this week's notes.
Hey, Mr. G.
Yes.
I missed the I saw the email from Miss Butler about scheduling the ready. I missed that too. Uh, do I have to email her or call her?
Yeah, so if you miss, so it's not about, that wasn't for the ready, right? That was just to practice the online, remember, because now you have to take it online. So that was to practice that. Yeah, you should email her about doing that again.
Okay.
Mhm.
And the classes that I missed, I could just go back and look at the videos.
Absolutely. Yep. Those videos are always going to be up and you're always going to be like enrolled in this class. So you can look at those videos at any time.
Okay. Do I still turn in the assignments too, or?
That's up to you, right? The assignments are for your practice, right? So if you want to see if you're doing it right, you should do it and turn it in, and then I can tell you, I can give you feedback.
Okay.
I don't know. I just finished with the pre-assessment, but I don't see where to submit it.
Oh, that's weird. It's usually the same place. You just have to click submit at the bottom when you're done.
Yeah, there's no there's I didn't see this the submit. I don't know what's going on.
Huh. I don't know. Let me check the system here.
Okay, okay, I got it.
Oh, okay. All right, guys. So you guys are all done. So let's go ahead and get started. Good work. Good. Right. All right. Okay, so here we are. This is going to be our last topic of the school year because tomorrow is December. Craziness. Okay. So we are talking about expressions. Sorry, let me pull up my PowerPoint. My slide is a little off. Okay. So we're going to talk about expressions today, and we're going to try to combine like terms. I'm glad to see actually that some of you remember a couple of these things, but still need some help with a couple of the other things. So it's good that we're having this conversation today. So if we look at the example that we have here in our warm-up, we have 3x parentheses 2 plus 5y. So it says, which of the following expressions is equivalent to that? And so what do we need to do to find the equivalent one? I saw that Tashelle already answered and she put in that her answer is C, but what are the steps that we have to take to try to get that answer? What do we need to do?
Multiply.
Yeah, you just got to multiply, right? So you have to distribute, right? Which is multiplication, right? But you need to distribute this 3x to the two terms inside the parentheses. That means I need to multiply the 3 to the 2, and I'm going to get 6x, right? So 6x is going to be part of my answer. So I know that A can't be one of the answers. And now I have to multiply the 3x times the 5y. So 3 times 5 is going to give me 15, but I have an x and a y, and they're not going to cancel each other out or anything, so both of them need to be in my answer. So my answer is 6x plus 15xy. y.
Oh.
Make sure you keep both of your variables. You need the x and
Oh.
the y, okay?
Okay.
Make sure you keep both of those variables. The y, the x can't disappear when you multiply them together. They just have to be combined just like that. So
Okay.
it's going to be 6x plus 15xy.
Okay.
All right, and we're going to talk about how we do this. We're going to look at it step by step in today's notes. So the answer is actually D for this one, right? We have an x and a y. Make sure you keep both variables in your answer. All right, let's try this next one. All right, it says if 3ab plus 2b cubed is equal to y, what is y when a is equal to 1 and b is equal to 2?
Okay.
So what do I need to do here?
Yep, you have to replace A and B with the number, with the proper number.
Perfect. All right. So I have to do what is called substitution, right? Or with good, you use the correct word there. Jules, yeah, it is replacing, right? It's we replace the letters with the numbers, right? So instead of A, I'm going to write 1. Instead of B, I'm going to write 2. So I have 3 times 1 times 2 plus 2, 1 cubed. Okay. So I can do the 1 cubed, oh, sorry, 2 cubed, excuse me. B is 2, right? So I need to do 2 cubed. What's 2 cubed? What's 2 cubed? What is that going to be equal to? It's 2 times 2 times 2, which is what? 8.
8.
Okay. So I have 3 times 1 times 2 plus 2 times 8. Okay. What's 3 times 1 times 2?
3 times 1 is 3 times 2 is 6.
Good. And what's 2 times 8?
16.
Good. So what's 6 plus 16?
22.
22.
22.
So that's going to be my answer. My answer is going to be 22. All right. So you just got to do it in a stepwise fashion. This process is known as substitution. And when you do substitution, you are replacing the variables with the number that you're given. And then you're just doing the math. Good. Yes, the answer is D. Very good. All right. So today we're going to take it very slowly and just kind of go through our definitions first of what we're talking about. We're talking about expressions and variables and all those things. Learn the difference between an expression and an equation. And of course, also an inequality. We're going to learn those definitions real quick. And then we're going to go into the notes. So I'm going to go into Schoology first. And there is a discussion question there. I'm going to pull up Schoology. And we have, what are the parts of an algebraic expression? So share one thing you can find in an algebraic expression and give an example if you can. So in this discussion post, you can do it right now or do it a little bit later, but what's one thing you can find in an algebraic expression? So do try to respond to that. But I'm gonna just go ahead and start off with our notes. I'm going to go right into our notes, which is the third item in our week 10 folder. The identifying expressions notes is our fourth item in that folder, excuse me. I'm going to open up those notes and we're going to go over those notes together.
So, Mrs. D, am I answering that question or just wait?
You're answering that question whenever you want to answer it, whenever you're ready to answer it. But hopefully by the end of the day today, you should be able to answer that question. What are the parts of an algebraic expression? Okay, let me pause my share real quick just to check on the notes. Okay, let's go into these notes now. All right. So an equation is a math sentence that states that two quantities are what? How do we finish that statement? It says that two quantities are what? What's an equation? A math sentence that states that two quantities are
10
equal.
are equal.
Okay, that's how we get the word equation, right? Because they are equal. So that means it has to have an equal sign. Okay, so I can only call something an equation, right, when it has an equal sign. Otherwise, it is not an equation. All right, so in this example here, it says that 3x minus 4 is equal to 7. So what it's saying to me is that what is on the left, which is 3x minus 4, right? That's what's on the left, is equal to what's on the right. And what's on the right is 7, okay? You have to remember that this is what every equation in math is telling you, right? It has that equal sign because it's trying to tell you that whatever is on the left is equal to what you have on the right.
Okay.
Okay, this whole thing, 3x minus 4, is equal to 7. All right. But what are the parts of an equation or an expression? Okay, well, there are several parts to an equation or an expression. An equation or expression is going to have a variable. What's a variable?
A number.
A number? What's a variable?
A letter.
Oh, good. It's a letter that represents a number we don't know yet, right? So in this equation, our variable is x, right? A variable is a letter that represents a number we don't know yet, okay? All right, every single variable in an equation or an expression has a coefficient, okay? All right, so the coefficient is the number that we see in front of the variable. That is what is known as a coefficient. So what is the coefficient in this equation?
3.
The 3.
Okay, so the number in front of the variable is the coefficient. That coefficient can be positive or negative. Okay, we can have a coefficient that is either positive or negative. It doesn't matter. It's still going to be called the coefficient, regardless of whether it's positive or negative. All right. What about in some equations or some expressions, I'll see something like this. Let me just write an example here. I might have an equation or expression that looks a little bit like this. It says x plus 2 equals 3, right? It says every variable has a coefficient. What's the coefficient in this equation? X plus 2 equals 3. What's the coefficient?
2.
What's the definition of a coefficient?
The number in front of the variable.
Okay, so why did you say 2? Is 2 in front of the variable?
No.
Okay, so what's the number in front of this variable?
Nothing. X.
1.
What is it, Jules?
1.
1.
1.
That's
Every variable has a
It's one.
coefficient. So if I do not see a number, right, in front of my variable,
one.
I know that my coefficient must be 1. Okay, how many x's do I have here? Only
1.
1 x. Whenever I have a situation when there's only one of my variable, I don't write the number 1, right? In math, we like to shorthand things whenever we can. And so whenever there's only 1, we don't write it, right? We just write the variable, okay? So remember this rule. Every variable has a coefficient. That means if you do not see it, the answer must be
1.
okay. All right. The other part that we have and the final part that we're going to have in an equation or an expression is a constant, all right? There may be more than one constant, there may be multiple constants, but a constant is any number with no variable attached. Okay? Any number without a variable is considered a constant.
Oh, man.
Okay, so that means if we go back to our example here, 3x minus 4 equals 7, can you give me a constant in that equation?
-4.
Good, -4 is a constant. Is there another constant?
7.
7. Okay, so any number that does not have a variable attached is a constant in an equation or an expression. Okay. All right, so in an equation or an expression, we have terms. A term can be any of the following: a single number, which is considered a constant. So 4 and 7 are terms, right? Well, in this case, because we have that negative sign, we should say -4 and 7 are constants, and they are both terms in this expression, in this equation, right? Because I have an equal sign, it's an equation. And they can be a single variable, right? Just like this variable x, if it were by itself, that could be a term, but with the 3, it's a term as well. So 3x is a term, right? Okay, which is what we have when we have the product of a number and a coefficient of variables. So in this equation, 3x minus 4 equals 7, we have 1, 2, 3 terms. Okay, so every single thing that is separated by a operation, right, or an equal sign is considered a term. Sometimes you are asked to combine like terms. We will get to that step in a second. But when you're asked to combine like terms, you are putting together the terms that are similar. In this equation, 3x minus 4 equals 7, what terms are similar? What terms are alike?
-7, -4, and 7.
Right, -4 and 7 are terms that are like because they are both constants. They are both numbers with no variable attached, all right? So we would combine those two together, all right? So we're gonna get to that step of combining like terms, but you have to understand that every single thing that is in the equation or expression is considered a term. Everything that is connected is a term, all right? So let's look at a couple examples down here. We have this right here. It says 2x plus 15 minus m minus 3 plus n minus 7p. How many terms do we have?
6.
6 terms, right? 2k, that's 1. 15, that's 1. Negative m, that's 1. Negative 3, that's 1. N, that's 1. And negative 7p, that's 1. So 1, 2, 3, 4, 5, 6. We have 6 terms. Okay. What are the variables that we have in this expression?
4 variables.
We have 4 variables. What are they?
K, M, and P.
Good. K, M, N, and P. Okay. How many coefficients do we have?
2.
Okay. What are they?
2
Two,
and 7. 2 and
2
negative
and
7.
negative 7, right? Don't forget that negative. It's negative 7. Okay. And how many constants do we have?
1, 2. 2 constant.
We have 2, right? What are those constants?
15 and negative 3.
15 and negative 3. Okay. So yeah, I just want you guys to be able to identify what a term is, your variables, your coefficients, and your constants. This is going to be very helpful, right? And these definitions are also very helpful because you are occasionally asked very simple questions on the GED where they'll be like, well, what coefficient is in front of this? And if you don't know what the word coefficient means, you will miss an easy question, right? You have to do no math. This is a definition question. You have to identify something. There's occasionally, you'll be very lucky. Sometimes you get 4, maybe 5 of those kinds of questions where it's just an identify question, where they ask you a definition of a math term, right? And you just have to be able to say, oh, I know what that means, right? What that word means. And if you miss a question like that, it's like, oh no, there goes free points, right? Because I don't have to do any math. I just have to identify something. So it's important to make sure that you understand what a term is, what a variable is, what a coefficient is, and what a constant is. All right. Let's look at this other example here. We have negative 8 minus 4c plus 7 minus c minus 12c minus 2. Oof. How many terms do we have?
6.
Again, we have 6. All right. What are our variables that we have?
1.
Just 1, right? We have the letter C. That's our only variable. What are our coefficients? How many do we have?
2.
Only have 2. What are they?
Negative 4 and negative 12.
Good. Negative 4 and negative 12. How many constants do we have?
3 constant. 3.
3, right? Good. We have 3 constants, right? They are negative 8, 7, and negative 2. All right, any questions for me so far? Okay, let's keep going. All right, so we haven't explicitly said it, but an expression, right, is what we just had here. These are examples of expressions. Why are these expressions and not equations? Why are these 2 examples expressions and not equations?
Because there is no we don't see the sign equal.
Right. There's no equal sign, right?
Yeah.
Because there's no equal sign, these are just expressions and not equations,
Sure.
okay? So an expression is a group of terms, right? It contains numbers, coefficients, and variables, but it does not contain an equal sign. Okay, so an expression is a group of terms. It contains numbers, coefficients, and variables, but it does not contain an equal sign. Okay. All right, so we have an example of an expression here, and we just need to label it. I need the coefficient, the constant, and the variable. So there are 3 students in class today. There are 3 things we have to identify. So you guys tell me which one you're going to identify.
I do the variable.
Okay, what's the variable?
Okay, it's y.
Y is my variable. Very good. Okay, so the second arrow is pointing to the variable. It's pointing to y, so that's my variable. Okay. We got coefficient and constant.
Coefficient is 8.
Okay. My coefficient is 8. All right, so that leaves -7 as my constant. Okay. How many terms are present in this expression? What are the terms? How many terms do we have?
3 times.
Good, we have 3 terms. Okay, our terms are in order 8y. Oops, sorry, my block is not working. Okay, it's 8y, -7, and 2y. Those are my terms. Okay, every single thing that's separated by an operation is a term. That's separated by a negative or a plus sign, right? Is a term. All right, we're going to do that again. Same exercise, but with number 2. We're going to identify the coefficient, the variable, and the constant. All right, so go ahead. You guys just tell me which one is what.
The coefficient.
Mm-hmm.
Is it 7?
It's -7, right? But yes, this is my coefficient.
And the variable.
Mm-hmm.
Is it 7m? -7m?
So -7 is your coefficient. Your variable is just the letter, which is m. Good. Okay, and so that leaves 4 as my constant, right? This is a number that does not include a variable, it's a constant. So 4 is an example of a constant, 2 is a constant, and 6 is also an example of a constant, right? I want us to go back up a little bit to some of our previous answers up here, right? So we identified in each of these expressions, we only identified 2 coefficients, even though we have 4 variables. So we are missing a couple coefficients, right? Because every single variable has a coefficient. So I want to remind you guys that m and n here, even though there's no numbers, that we still have coefficients. For m, we have the coefficient of -1 because it's a negative m. And for n, we have the coefficient of 1, right? So there's 4 coefficients. Your coefficients plus your constants should always equal the number of terms that you have. So the same thing is missing over here in this term, because we left off this coefficient, we left off the -1, in front of that coefficient. So don't forget, guys, to always include a coefficient of 1 for those variables that don't have a visible coefficient, right? If there's no visible coefficient, there is always a coefficient of 1 or -1. Okay, just a reminder there. All right, let's continue on with number 2. So we have the variable, the constant, and the coefficient. How many terms are in this expression?
Five.
Let's count them. How many?
5.
5, good. So we have 5 in this expression, and we're just going to list them in order, right? So they are m, 4, 2, -7m, and 6. Those are the terms. All right, so we're going to move on to this next section where we're doing the same thing, but we're just identifying them in a different order. Okay, we're going to identify the terms, the variables, the coefficients, and the constants in each expression. Notice how much time Mr. G is spending on this, right? This is very important. You have to get this concept down in order to move on to the other parts. So you really need to be able to identify a term, a variable, coefficient, and constant. All right. So for number 3, we have -4a minus 7b plus 5 plus c. How many terms do we have?
4.
There are 4 terms, right? -4a is 1, -7b is another, 5 is another, and c is another. So we have 4 terms. What are the variables that we have? How many of them do we have?
Is it 1? No, 2.
3.
So we have 3, right? We have A, B, and C.
Okay.
So that's 3 variables. Every letter is a variable.
Okay.
So we have A, B, and C. Those are our variables. Okay, we have 4 terms. How many coefficients do we have if we have 3 variables?
2.
If we have 3 variables, we should have 3 coefficients.
Huh?
3.
Every variable has a coefficient.
Oh, okay.
So what's the coefficient for A?
-4.
-4. What's the coefficient for B?
-7.
-7. And what's the coefficient for C?
1.
1. Every variable has a coefficient.
Okay.
Okay. There's always a number in front of every variable. Okay, so we have 4 terms. We know that 3 of them have variables. That means how many constants do we have?
1.
1, right? Your terms minus your variable should always equal your constants. Or another way to say it, your constants plus your variables equal the number of terms that you should have. So there's only one constant here, and that's the number 5, right? That's the number 5 is the only number that is not accompanied by a variable. Okay, so using the same concept that we just did in number 3, I want you guys to do number 4 on your own, and I'm going to come back and check on your answers in a minute. So I'm going to give you a minute to just work on number 4 on your own, and then we'll see if you guys got the right answers. All right, you ready for some answers for me? How many terms do we have?
I put 3,
3 terms? How many do you see? What do you see here?
7,
Uh-huh.
5,
5H.
5H,
Uh-huh.
and 2,
And then,
and 1.
so those are not your terms, right? Your terms is everything that you see.
Okay.
So each one that you see up here is a term. So 7 is a term,
Oh.
negative 5H is a term, negative
Mhm.
2 is a term, and negative K is a term. So there are 4 terms.
Oh, okay.
Each
I thought.
individual piece is a term.
Oh, I thought when you didn't see a number for K, that means it's 1.
Those are your coefficients. That's a
Oh,
different thing.
okay.
All right, so there are 4 terms here. All right, and I can list them out. Let me just list them out. 7, negative 5H, negative 2, negative K. Those are all my terms. All right, how many variables do I have?
2,
Okay, what are they?
H and K.
Good. All right. How many coefficients do I have?
2,
2. Good. What are they?
7 and 2.
Nope. Those are my constants.
Oh, what? Is it
A
5?
constant is any number without a variable.
So it'll be 2 and K.
All right. So for my coefficients, right? Your coefficients are the numbers in front of your variable.
Mm-hmm.
So what's the number in front of my variable H? What's the number in
5.
front of it?
5.
Negative 5.
Oh, negative 5. Okay.
Uh-huh. And what's the number in front of K?
2.
What's the number right in front of K?
2, right?
Nope. That 2 is not part of the K term, right? It's separate because there's a minus sign. So it's just negative 1.
Okay, negative 1. Okay.
Okay. And then your constants are what you said before. Your constants are 7 and negative 2. All right. So remember, you have to remember your definition. So we have 2 constants, sorry, and your constants are 7 and negative 2. So this all goes back to like making sure that we have our definitions, right? And that we're using our definitions kind of effectively to get our answers. So if we go back to our very first page of notes, we have our definitions right here, right? It says every variable has a coefficient, right? What is the coefficient? The coefficient is the number in front of the variable, right? That means the 3 is a coefficient. A constant is a number with no variable attached. So the numbers with no variables attached are -4 and 7. Those are our 2 constants, right? A constant has no variable, no letter. A coefficient is attached to the variable, okay? When I don't see a number attached to the variable, I assume that that number is 1, okay? All right. All right, let's try number 5 together, and then you guys are going to do number 6 on your own. So how many terms do we have in number 5? We're going to count them. We have 1, 2, 3 terms.
Okay.
Okay, those terms are 5, -4x, and -8y. Those are our 3 terms. How many variables do we have in number 5?
2.
We have 2 variables, x and y. Okay. If I have 2 variables, I have to have two coefficients. What are those two coefficients?
-4, -8.
-8.
8.
-4, right, is in front of the x. -8 is in front of the y.
Y.
Those are my two coefficients. All right, how many constants do I have?
5.
Two.
How many?
5.
How many do I have?
5. 4.
How
One,
many
2,
constants
3.
do I have?
4.
I didn't ask you which one is a constant. I asked how many do I have?
3.
4.
1.
5.
I only have one constant. That constant is 5,
5.
right?
Oh, okay.
Right. So the question was, how many constants do I have? I only have one constant. 5 is the only number that is not attached to a variable. Okay. So that's what makes it a constant. So answer the question and then identify it. Okay. Right. So I only have one constant. That constant is 5. All right, so use the same method that we used to do number 5 to try number 6. So identify the terms, the variables, the coefficients, and the constants. All right, let's go ahead and go over it. Jules giving his answers already. I'm going to put them here as well. How many terms do we have? We should have 4 terms, right? 9k, 7, -k, and 4.
that's
Those
a
are my 4
negative
terms.
K?
Okay, what are my variables? How many do I have?
2.
2.
What are my 2
2.
variables?
9K.
K.
And
So then how
4.
many variables do I
Oh,
have?
it's only one.
One variable, and it's
What?
k.
One variable and it's K.
Okay.
Same thing.
All right. What are the coefficients in front of my variable?
9
So I have 2 of
and
those. I have
+4.
9 and -1. Right? 4 is not in front of a variable.
Oh,
4 is by
K, because
itself.
K, -1.
All right. I have 2 constants. What are my 2 constants?
7 and 4.
Perfect. All right. Good job. All right. In this case, we have a situation where there's only one variable, right? The variable that we have is k. It appears twice, but we only have one variable. The letter is the letter k.
Hey, Mr. G, I thought that was 7 minus K plus 4. That's a negative K.
So how is this minus any different than any of the other minuses we saw before? You know what I mean? Right? All of the expressions that we've been looking at have minuses, right?
Okay.
Anytime you have a minus in front of something, you have to count it as a negative, right? So it doesn't matter where it appears, but it makes that term negative,
Okay.
right? So up here, we have a minus k. And so when the term is a negative k. right? And the coefficient is -1, right? Anytime you have a minus sign, it makes that term, when you identify the term by itself, it makes the term negative,
Okay.
okay? Okay, so we're gonna leave you with one last thing, is identifying an inequality. So we learned how to identify an equation, right? An equation is essentially just an expression with an equal sign, right? And an expression doesn't have the equal sign. And an inequality is a mathematical sentence that contains the symbols less than, greater than,
two,
less than or equal to, which I'll just draw because I,
Woo.
thing but the underline.
yes. Less than or equal to, don't forget how to put that in there. Sorry, my marker keeps going away. Less than or equal to, and then greater than or equal to, okay? Those are your 4 symbols, right? And you have them down here, so you can name them, right? So this one is greater than.
Oh,
This
Lord.
is greater than or equal to.
Greater than.
Or equal to. This is less than. And then the last one is less than or equal to. Less than or equal to.
Two.
Okay, so with this is your last thing that we're going to do on the notes for today. We're going to finish up the rest of these notes on Wednesday. Please make sure that you answer your discussion question prompt today. All right, so go back into your folder. So the things that are required for today are to do your pre-assessment, which you guys have all done, and to also answer that discussion question, okay? Because we didn't finish the notes, there's nothing else that you can do today. So those are the only 2 things that must be done today. On Wednesday, we will finish these notes and you will do one of the practices as well. Okay?
Okay.
Okay.
All right. Have a great rest of your day.
You
And I will
too.
see you all on Wednesday.
Okay.